evaluate using sum and differences where pi by 2 and pi are involved, and then another one that's going to bring us way back to chapter 6. So this next one will say find an equivalent expression for each of the following, and what you'll notice is that there'll be a pi by 2 in it or a pi. What's going to happen is that all of these are going to evaluate to ones and zeros and negative ones, so they're going to all simplify quite a bit. So for example, if I look at the cos of pi by 2 minus x, I know that this is a cos difference identity. So I'm going to write it out. So cos difference identity goes cos cos plus sine sine. Here we go. We're going to go cos pi by 2 cos x plus sine pi by 2 sine x. And then we're going to evaluate we can. So anytime you have something with an angle, you can evaluate, and anything with an x, you cannot. So we're looking at pi by 2. Again, that's up here. It's a 0.01. Cosine follows x, sine follows y. Or you can draw your pictures and see what's happening, right? So the sine graph goes to 1 and the cos graph goes to 0, right? Same idea. So what happens is we get 0 for the cos of pi by 2 times the cos of x, and then we get 1 for the sine of pi by 2 times the sine of x, and then that would simplify to just sine x. All right, this one's a little bit harder because it's tan. So again, let's take a look at it. So the tan of u minus v, you do tan u minus tan v, and actually, you know what, for this one I don't have my tan ones memorized because we don't use them that often, and then randomly they pop up. So just shrink this guy down. Okay, so let's follow out my tan difference identity. So we are going to go tan of the first angle, so tan of x minus the tan of pi over 1 plus, so opposite sign, tan of x, tan of pi. And then we're going to evaluate. So again, we can't do the x's, but we can do the pi. So when we think about tan, right, tan theta is opposite over adjacent, which is the same as y over x. So if we're at pi, that's all the way over here, which is going to have a 0.10. So tan x will stay tan x. Tan of pi is y over x, or 0 over 1, which is just 0, all over 1 plus tan x times 0, which is going to leave us with tan x minus 0 is gone, over 1 plus 0, which is 1, which is just a tan x. Awesome. Maybe see, oh, maybe not. I was like, maybe pause the video. Maybe not. This one's a bit tricky. So this one, we don't have a secant, a cosecant, or a cotan sum and difference identity. So what you would do first is write this as 1 over the cos of x plus pi by 2. And then you're going to evaluate it. So for this one, I'm going to have 1 over cos of the first angle, cos of the second angle. Switch my sign. Sine of the first angle, sine of the second angle, and then I'm going to evaluate. Oh, I'm running out of room. I get 1 over, now let's just kind of cheat this. So cos of pi by 2 is 0. So this whole thing is going to go to 0, and then sine of pi by 2 is 1. So I end up with 1 minus sine x as my answer. Before we go on to the next question, I should point out to you as well that you know how we did this one as secant is 1 over cos. I'm not super comfortable with my tan sum of difference identities. Now, it wasn't hard to look on the sheet and copy it, but if anybody's like really adamant that they love the sine and cosine ones, you can write this as the sine of x minus pi over the cos of x minus pi, and then you can evaluate as such, and we will get the same answer. So the answer must turn out to sine x over cos x, which could simplify to the tan x. Up to you. All right, last question that we are going to do in this section is one of these guys, where they tell you, assuming sine theta is 2/3, what they're telling you is that opposite over hypotenuse is 2 over 3. Now they're telling you that the angle is between 0 and pi by 2, so we know this is in the first quadrant, which just tells you that everything is positive. So theta is going to be 2/3 opposite over hypotenuse. And then they also are telling us beta, also in quadrant 1, is going to be a half, 1/2. And what they want us to do is evaluate sine of beta plus theta. Now, a lot of people try to be like, oh, beta's a half and theta's 2/3. I'm like, no, it's not. Sine theta is 2/3 and sine beta is a half, but not beta and theta. So we're going to be thinking about expanding this out as sine beta cos theta plus cos beta sine theta. And then what we have to do is make sure we can evaluate these. So we know sine of beta is a half, but we don't know cos of theta. We don't know cos of beta, but we do know that sine theta is 2/3. So to find cos of theta and cos of beta, we complete these triangles just using Pythagorean theorem. So 3 squared, actually let's just, x squared is equal to 3 squared minus 2 squared, which is 9 minus 4, which is 5. That's what x squared equals. So x would equal plus or minus the square root of 5. Now, since we're in quadrant 1, it's obviously positive. And then we do the same thing for this guy. Now, if anybody knows, this is my 1, 2, root 3 triangle, but you can do it as well. So x squared would equal 2 squared minus 1 squared, which gives you 4 minus 1, which is 3. That's what x squared equals. So x would be plus or minus the square root of 3. And now we can find cos theta and cos beta. So cos theta would be root 5 over 3. And cos beta would be root 3 over 2. Now, we still get common denominators. So 1 times root 5 is root 5 over 6, plus root 3 times 2 is just 2 root 3, all over 3. Sorry, 6. I was all excited about the common denominators and then I messed up. And then because I have that common denominator, I can write it as a 6, and then I've got root 5 plus 2 root 3 in my numerator. Awesome.